So today we're going to look at solving type 1 equations. So one of the key words whenever you see this in math lessons and you see the word solving, what you're going to be looking to do is you're looking to find the value of a variable. You should know what a variable means. Variable just means the letter. So if you have, let's say the letter x, you want to find out what exactly does the value x represent. What number does it represent? So these, what we call type 1 equations, are the simplest of all the types of equations that you can possibly solve. So let's look at the following, what a type 1 equation is. So when solving type 1 equations algebraically, using addition, subtraction, multiplication, whatever, we use the opposite that is displayed to determine what value our variable has. Okay? So if you don't understand what the wording means, pay close attention to the examples that we're actually going to look at. Now, what we mean by do the opposite, well, here's the opposites. Addition is the opposite of subtraction. Subtraction is the opposite of addition, so vice versa. Okay, so if you've got addition, the opposite is subtraction. If you've got subtraction, the opposite is addition. Next thing, let me get rid of this, get it away. Multiplication is the opposite of division. So if you're multiplying on one side of the equal sign, you're going to divide. If you're dividing on one side, when you move it to the other side, you will multiply. So that's what we mean by opposites of, opposite of what's displayed. And I'll show you more, like I said, focus more on the examples that we do. Variables are considered unknown values, and we're going to use the letters UK, and I'll show you guys that in later on. So because they can represent any value. Okay. So here are a few examples: 2x, 8y, and this actually is supposed to say 4x to the power of 2. These can represent any number, right? Because 2x, this variable, can be any number we want it to be. Okay? Whether it's something we want it to be or something it has to be. But we don't know what the value is because we need to find what this value is in order to solve such a problem. So this is why we consider it an unknown, because this can be any number depending on what that x value is. And then we have numbers, or something called constants, which are known as known, and we're going to use the letter k to designate that, k values, because we know the value of the number. So here are a few examples: 5, 8, 12. Notice that these known values do not have any letters. We know what the value is, right? If it says 5, we know the value. 5 is 5, right? We have 5, I don't know, apples, bananas, oranges. It could be anything, but we know how many. But if we said like this, here we have 2x bananas, 2x apples, right? Who knows how many we have? We have to find out what that x is. So that's why anything that consists of a variable, right, is considered an unknown value. And anything that is known as a constant is a known value. So, now what we're going to do when we're solving, one thing you're going to notice whenever solving, you will have an equal sign. Now, imagine the equal sign when you have as a wall separating the left side of the equation from the right side of the equation. So, we're going to separate what we call unknown values on one side of the equal sign and the known values on the other. Okay, so just like this. So if we have an equal sign, we're going to put everything that is, let's say, unknown, right? Anything that includes a variable. So all variables, let's say, will be on one side. Right? All the known values will be on the opposite side. So you're going to see mixing and matching. It's going to be up to you to be able to combine them together. So let's look at some sample problems. So here's addition. So we have x plus 8 is equal to 14. So this is what I was mentioning about. We've got our equal sign. The question is going to ask us to solve. And I didn't put it. So let me just throw in that word. So the question says solve here. So solve x plus 8 equals 14. So this is what we do. Imagine where the equal sign, this is that wall that we're separating. So as we said, we are going to put what we call unknown values on this side of the equal sign, and everything that is considered a known value on this side. So let's label the following. Let's label each term. So this term x is a letter, and it's a variable. So this is what we call an unknown value. We're going to treat the sign that's in front of each number with the number following it. So this +8 is considered a known value because we know the value of it. +8 is +8. Over on the other side, we have 14. This 14 is also considered a known value. We know the value of it. So what we're going to do now is on the left side, we are going to collect our unknown value. So let's follow along this left side. This x value is an unknown value. So it's on the side that we want it to be. This +8 is a known value, right? It is on the wrong side. We want to move it now to the other side. So when we move it to the other side, it will become a -8. So this is what I said at the very beginning about doing the opposite. So if it's positive on one side, when we move it to the other side, it becomes the opposite. So if we're adding on the left side, when we move it to the right side, it becomes the opposite. So it goes from +8 to a -8. Now, this 14 here is a known value. It's already on the correct side, right? It's on the known side. So 14, what is a sign? Well, it doesn't have one, which means it stays. It doesn't become, and then we didn't move it across the equal sign, so we do not use the opposite. So in other words, we have x is equal to -8 plus 14. So you could throw that into the calculator. The value of x is equal to 6. Now, you can always go in and throw this and do a check. So if we have x is equal to 6, right? We throw it into the equation. So x plus 8 is equal to 14. So instead of x, we are going to put in those brackets. We're going to put the number 6. And then we're left with the +8 equals 14. 6 plus 14, or sorry, 6 plus 8 is 14, which equals 14. So we've proven it correct. So we've proven that the left side is equal to the right side. So we have solved for our unknown, which was x. And simple, these type 1 equations only deal with one step. Look at, we only had one step, and that was to move this +8 over to the other side to become -8. And that's what we did. Let's look at the next example. Type 1 sample problem. Now we're dealing with subtraction. So, again, question says to solve for the unknown. So, we separate the left side from the right side. So, as we said, unknowns on this side, known values on that side. It doesn't really matter. You can put unknowns on the right side and knowns on the other. It doesn't really matter. Try to move it so your unknown can stay positive. Okay, because it makes things a lot simpler. So let's identify. X is a unknown value. This -8 is a constant, so it's a known value. This 5, which is +5, is also a known value. So we've got our equal sign. What do we have on the left side? What should stay? So this x here should stay, right? Because we're going to keep the unknown values. This -8 is a known. It's not to be on this left side. We want it on the right side. So -8 becomes +8 when we move it across the equal sign, right? The 5 is on the correct side, so it's just +5. So this one's really simple. X is equal to 8 plus 5 is equal to 13. So we can do a check. Now we can check this and say, well, if x is equal to 13, let's throw it into the equation. X is equal -8 is equal to 5. So instead of 5, I am going to put 13. So 13 minus 8 equals 5. So 13 minus 8 is equal to 5. So both left side is equal to the right side. So yes, I am correct with x is equal to 13. Next type of sample problem. So we're going to be dealing with here what we call multiplication. So the question asks us to solve again. So solve for the unknown. Solve for x. So now we have, right, again, same thing. We want to separate our unknowns from our known values. And one of the great things about multiplication division, if there's only in these type 1 equations, if there's, so if it's a type 1 and it's multiplication and or division, usually the steps are already set, right? And this really goes more with the multiplication. Notice here, negative 3x, this is considered an unknown value, right? Already on the right side, on the correct side. 21 is a known value. Notice the equation is already in the order that we want it to be, so there's nothing for us to change. The only thing is, right, I'm going to rewrite the equation, so that's what I'm just doing right now. I want to solve for x. I do not want that negative 3. So whenever I have a variable multiplied by a whole number like this, I want to remove this number here in front of the x. So what you do, the step that you do to remove it, is you divide by whatever number is in front of the x. So what number is in front of the x? It's a 3, but it's not just a 3, it's a negative 3. So if you know your division, and you know that anytime you divide two exact numbers that are exactly the same, they equal to 1. So in other words, all I'm left with, we can kind of say they cancel out, but it's not really considered proper terminology to use, but we can use it as cancel out. And all we're left with on this left side is x. But remember in math, whatever you do to one side, you must do to the other. So if we divided by negative 3, the left side, we must divide by negative 3 on the right side. So 21 divided by negative 3 is equal to negative 7. So we can do a check, right? Take this negative 7 value, put it in here. So negative 3 multiplied by negative 7 will give me positive 21. So my answer is correct. Type 1 sample problem now when we're dealing with division. So what we have here is, again, same thing. We've got now really, we're separating the left side from right side, our unknown and our known value. So we're going to keep it the way it is, but the only difference is the following. Whenever we have something like this, right, we can rewrite this as x over 5 is equal to this whole number. If we want, we can write it as a fraction as 4 over 1. So I'm adding an extra step, right? And all I'm doing now is I'm crossing over from the denominator to the opposite. So the function here between this x and 5 is going to be division. When I bring it across the equal sign, it will become multiplication. Okay? So when I cross them over, I'm going to get x times 1. We can use the dot to represent times. On the other side, we're going to have the 4 here, which when we bring the 5 over becomes times 5. So x times 1 is just going to stay as x. 4 times 5 is going to equal to 20. So this is one way of doing it. The other way what we can do is going back to the first example, or to the way I first wrote it, is, well, what am I doing between x and the 5? I'm going to divide by 5. So if I want to bring this 5 across the equal sign, it goes from being divided on one side, and the opposite is multiplication. So I'm going to be left with x is equal to 4 times 5. And so x is equal to 20. Right? So which is exactly what we got. We can do a check by taking that 20 and putting it into this equation. So instead of x, I'm going to put 20 over 5 equals 4. 20 divided by 5 is equal to 4. So I know I've done my question correctly. Now, let's do some more sample problems. So the question says, solve for the following. Now, same thing as we've done before. We treat the equal sign as a wall separating the left side from the right side. We are going to put our unknowns on one side, our known values on the other. But notice we have the equal sign that carries over. So let's identify these. This -7 is a known value. This positive x is an unknown value. This positive 13 is a known value. So what we're going to do is we're going to collect the unknown values here on the left side. So let's look at this -7 is a known value. Is it on the right side, on the correct side? No. We need to move it to the other side. So when we move a -7 to the other side, it becomes a positive 7. This positive x doesn't change. It stays where it is. We remember, if something's positive, we don't need to really put it if it's the first term that we're writing down in our equation. Now, this 13 here is positive, but we have to write down that it's a positive 13 because really we're saying that we are going to add the two terms. So our x is equal to 7 plus 13, which is equal to 20. So now, what you can do the check as I've explained before into the original equation to see does it equal to, both sides equal to one another. Now let's look at this last example. Remember, as we said with type 1 equations, it's already unknown and known. So nothing is going to really change. So what I'm just going to do is I'm just going to rewrite the equation. Right? And remember what we said, we want to isolate for x, right? But it's 5x. So to get rid of the number in front of the x, we divide it by that number. So the number in front of x is 5, so we divide that by 5, right? Because 5 and 5, as we said, technically it's incorrect math, but we say it canceled out and all we're left with is x. But remember, what you do to one side, you must do also to the other. So we're left with x is equal to 30 divided by 5, which is 6. And we can go back in to the original question to do our check. So 5 times x, so 5 times 6 is equal to 30. So we know that this answer is correct.